Morning to one and all. My name is G Somesh and I am from EC branch D section. Today's topic about source transformation. Source transformation is the process of simplifying a circuit solution, especially with mixed sources, by transforming voltage sources into a current sources and vice versa using Thevenin's theorem and Norton's theorem respectively. To analyze the circuits, we can apply simply voltage and current divider techniques by using this transformation. Source transformation for different dependent sources. Source transformation is applicable even for the circuits with have dependent sources. Process of source transformation. Performing a source transformation consists of using Ohm's law to take an existing voltage source in series with a resistance and replacing it with a current source in parallel with the same resistance or vice versa. The transformed sources are considered identical and can be substituted for one another in a circuit. Source transformations are not limited to resistive circuits. They can be performed on a circuit involving capacitors and inductors as well as by expressing circuit elements as impedance and sources in the frequency domain. In general, the concept of source transformation is an applicant frequency Thevenin's theorem to current source or Norton's theorem to voltage source. However, this means that source transformation is bound by the same conditions as Thevenin's theorem and Norton's theorem, namely that the load behaves linearly and does not contain dependent voltage or current sources. Applications of Thevenin's theorem and Norton's theorem gives the quantities associated with the equivalence. Specifically, given a real current source which is an ideal current source in parallel with an impedance, applying a source transformation gives an equivalent real voltage source which is at an ideal voltage source in series with the impedance. This impedance returns its value and the new voltage source has an equal value to the ideal current source's values times the impedance according to Ohm's law. In the same way, an ideal current voltage source is an in series with an impedance can be transformed into an ideal current source in parallel with the same impedance where the new ideal current source has the value I is equals to V by Z. In any circuit, if any circuit is having this voltage source in series, it can be converted into current source with parallel with that resistance. This process can be reciprocated. If two current source L1 I1 I2 is connected in parallel, then there is addition of both the current, and if both the current are connected in series, then the current is same in both the sources. If voltage source is connected with resistance in parallel, then the resistance can be neglected. If current source is connected with resistance in series, then the resistance can be neglected. Source transformation example with the dependent sources. The VCVS and the 12 is series resistance likewise convert to a parallel structure with the source current of so the VCVS becomes a VCVS whose trans conduct is 0.255, but now all the three resistance can be combined as the following, which will be the 2 ohms. If the same value of load resistance RL is connected to the resistor of the following figure, the load current flowing in circuit A is. Now we can by that we can we can give the expressions and we can solve the derivation with the below formula is represented. Some of the source transformation circuits. These are the source transformation circuits. Thank you.